Okay, hello everyone. Here in this video, I want to just see all the six trigonometric graphs. I'll begin with the sine graph. So first one, what I did is I tried to make an input-output here with the multiple of 30 degrees, which is pi by 6. I started with minus pi. There it is, minus pi right here. Here it is. And increment of pi by 6 went all the way to 2 pi. I did not round it to like this. Let's see, this part it is 2 pi by 6, but I'm gonna use 2 pi by 6 instead of saying like pi by 3, just to show that it is multiple every time it increases. Now, to understand the sine graph, okay, what I'm gonna show is in the sine graph we have seen that we use the unit circle. So that means this part. If I try to show the unit circle. Okay, so if this is the unit, any point on this, let's take 60 degrees from this point is, let's imagine this is 60 degrees. And there we see that there is we can think of, so we can think of the point 60 is, and that's pi by 3. And cosine 60 is half, and sine 60 is root 3 over 2, right? So I'm going to use the other one. This will be 30 degrees. So that will be, that would be cosine 30 is root 3 over 2, and sine 30 is half. So I'm going to use this only the y values. Like this is 0, 1, and this will be, so my main focus is the y coordinate, that is root 3 by 2 here. This one, and this will be half again, and then minus 1 comma 0. So we are using, the main thing is this one. So this is sine, right? So using this, you can see that in the beginning it is 0, 1, 1, 0. So it starts with zeros. So 0 is small, then goes increase by, so increases, decreases. So that part is shown right here. So all those points are put, put right here. So I'm going to use sine x. So here it is sine x. So use sine graph, and you can see there the graph of sine function, right? So what I'm going to do is I want to know those points from the unit circle where I made an input-output table, and I'll just say those are the points. So this is minus pi 0, minus pi by 6, and see it's going on increasing. And there you go. Those are the main point. So sine 0 is 0, sine pi by 6 is half, sine 2 pi by 3 is 0.86, sine pi by 2 is 1, sine 2 pi, and all these points can be seen. So this is the graph of sine x. And you can clearly see the maximum it takes is the 1. That's the maximum. I can even put that y equals 1. So that's the maximum. And I can also put another one, y equals minus 1. And when you put, so these are the two, so the graph ranges from minus 1. So this is minus 1 to plus 1. There you go. So the range of the sine function is minus 1 to plus. And the domain is, you can plug in any angle here. So this is the understanding. It's like, and it also wavy shape, start from 0, goes round, and watch this. If you see the thing, I'm gonna show also. Let me add this and try to show you starting with 0. I don't want, I want to start with P is 0, and then let me take this sign off. Okay. And then I want to make the Q. So So this cube, if you see, until 2 pi, this is the main graph of sine function. That means this cycle, we call it a period. What you see, what it goes up, then goes through pi, then goes down. That's the one. Then the same thing repeats for another 2 pi. So if I pull this up this side, so 2 pi will be, let's pull this up, 4 pi. And then the same graph goes, see, it goes and then goes to, it doesn't show 4 pi, it doesn't cross that because of our limitation here, or I can put this as 4 pi, see that? And there you go, it's the same thing, graph. So we say the period of sine function is 2 pi. And also the amplitude. So what is amplitude use? The maximum from the x-axis. That's the distance from this point to the x-axis is 1. That's the amplitude. You can also remember amplitude as okay. We can go back here. Let me take the transparent full screen. No, okay, here. If you see so the main thing what I wanted to show was uh, okay. So this is the main graph of sine until 0 to pi, and then it repeats. This part is there just a repetition. So we say, okay, the whole thing is called the period, which is 2 pi. In physics, we call it wavelength, also wavelength. And then this period has a maximum. This is the amplitude. This distance from the maximum to this. Or there's another way to remember amplitude as it is the maximum minus the minimum divided by 2. So in this example, the maximum is 1 minus minimum is minus 1. If you this will be plus, and if you work this out, you get 1. That's it. So the graph doesn't have to be I can change this. Let me use, and instead of sine, this is sine graph, and I can write this function. Okay. So this graph, I can move it up and say plus 7, see, and you will see. So there are two graphs. One is sine x. So the orange color is the one that you see, which is marked here. That's the orange color that I showed. And now I suddenly try to shift the graph to 7. See this graph? So this is the graph of y equals sine x plus 7. So the maximum is 8, the minimum is 6. So 8 minus 6, 8 plus 6 is 14. And if you divide by 2, you get where the graph shifted to. So in the beginning it was at the origin, now it shifted 7 places up. That's all that means. Plus 7 is where it shifts up. Or you can just write down here, put a 2, and then you see it goes up by 2. That's the amplitude. So the main thing is just to understand, hey, sine graph is, okay, so far I showed you the sine graph, right? Let's take it for cosine graph. So what if I change this to COS? And let me put type here and then put it COS. And the cosine graph, let's go down and you'll see the cosine start from up and then goes down. Look at this U shape. So this is like a cup until 2 pi, and the same cup again repeats. So again, the sine graph and the cosine graph is almost the same. They have the same range. The only difference is if I click here, yeah, cosine and sine, uh, this is a cosine, and if I try to type in here, maybe and just put a sine x, you can see sine start from down, goes up and until 2 pi. But the cosine begins from up at 0, 1 and then goes down. So that's how the graph of sine and cosine are related. Both have the domain, and the domain is could be any angle, and the range is, as I said, from -1 to +1 because that's the maximum and the minimum. Okay, let's go and check what about cosine. Okay, so let's put this part. Let me take this off everything. And how does the graph of put 10x? Let me put 10 function and I'll put 10x here. And click. There you go. This is the graph for 10. Watch this. So beautiful. Now, what I did was this. Let's take it little begin from. Okay, look at how the graph so beautiful. And in this example, let me make some changes here. I don't want too much of maximum. Let's make it 2. And the minimum I'll take -2. So that we can see have a better picture here. And also I don't want maybe 1. Let's put it like 1 and -1. Now I think we'll make it 2. And we don't want this too much of on the left. I'll delete like minus pi. Let me take it till minus pi. And this I'll make 6 pi, maybe 4 pi, or 3 pi, maybe 2 pi. Okay, and look at it, so beautiful. Now let me make it smaller, and that's how I'll make it bigger so that we can see all the angle. Now for the tan graph, this is how the tan graph looks. It's like going down and all covers the whole y-axis, right? But there is somewhere it goes up and then suddenly there's a break, right? So why? So let's see. If you see that's pi by 2, and at pi by 2, you'll see it is undefined, and you can see also it's this means it is 3 pi by 2, and also so this is pi by 2, right? So I'm gonna write here, and I put x equals pi divided by 2. Watch this. Make it dotted. Okay, and you'll see that's like a vertical asymptote where tan of pi by 2 is undefined because tan is sine over cosine, right? Sine pi by 2 is 1 and cosine pi by 2 is 0, so it cannot be defined. And not only that, it also has every multiple of, so if this is 3, and then I can say x equals 3 pi by 2. Okay, and you have pi by 2, sorry. And so there you go. So these are, and I can also click here minus pi by 2. And there's another one. So all these are vertical asymptotes. So we cannot have multiple of pi by 2. So if we say domain is, you can plug it in any angle for tan, but you cannot have, that's why we have that. So in other words, x cannot be pi by 2, x cannot be 3 pi by 2, x cannot be 5. All this, in other words, there's a 1 here, 1, 3, 5. Not only that, plus minus, plus minus, plus minus. So we say, hey, odd multiple. So we cannot have odd multiple of pi by 2s, or you can just write 2n plus 1 and pi by 2. So the domain means you can have any angle x, but x should not be 2n plus 1 for all and integers. See? So beautiful. Not only for pi by 2, as the same thing also for secant. Because if you see the secant, is 1 over cosine, and the tangent is, so not only this, you see, what is the definition? What is secant is 1 over cosine, right? And the tan is also 1 sine over cosine. So both have the denominator. You can't have, and cosine will become is 0 for multiple of pi by 2. So both cosecant and tangent. So we'll take a graph of secant also and see how that is seen. So let me see the secant graph. So if I click here secant, the secant graph, and if you minimize both the tangent graph, so this tangent graph, the orange color, and the secant graph, they both at this place they go become big, become infinity to the pi by 2 here. But when it goes crosses pi, they go start with minus infinity. So that's how. At the same time, what we see observe is the secant, the domain of secant is, and the tangent is the same. You can't have pi by 2, you can't have 3 pi by 2, you can't have minus pi by 2, and so on. So anyway, the main thing what I wanted to show is the tangent and the secant, they have the same domain. And then you also notice that for the secant, the range is above minus 1 and below plus 1. For the tangent, it just goes down all the way minus infinity. So let's get that clear. So the graph of, now this is the main thing for the graph for this one. See this is tangent graph, right? It goes this way, it goes up. That's tangent graph. It covers the whole y-axis. So the range for tangent is minus infinity plus infinity, but the but if you check the graph of secant is like this way, right? It goes lowest is minus 1, and so the lowest it goes to plus 1, and then here there's a in between is empty, right? This is empty. So that means the range of secant. Okay, now I'm saying what is the range of secant is from minus infinity, it means goes down till minus infinity, all the way till minus 1, includes that union, and again 1 to plus infinity. So that's the range of secant. Not only this, even if you check for, if you see the, let me take this secant off and make cosecant. Now see, it's cosecant also. Let me take the tangent off here and see the secant. So this is for cosecant. Let me take out this. Okay. So this graph is cosecant. And let me put a graph of cotangent also at the same time. That's better. Cotangent is a graph that looks this way. So tangent and cotangent, if you remember, the tangent graph was this one, which goes down up, and it completes the range. The period of a tangent is, if you, I did forget about that. If you look, let me put this back here. So the graph, see, from minus pi by 2, pi by 2 is the same rapid. So from here, minus pi by 2 to pi by 2 is total is pi, and it repeats. See, so whatever the graph from minus pi by 2, pi by 2, it repeats from pi by 2 to 3 pi by 2, and again it will repeat for pi by 2 also. Now I could have just enter another one and say x equals pi divided by 2. There you go, see, change the color. Okay, so the main thing here is the period of the tangent is pi because the graph repeats every pi, or the wavelength is pi. So hope this helps. And in this example, see if I can put that term, and you can see if you see this pi by 2, so this is minus pi by 3, minus pi by 6, 0. And the same thing is repeated. Look at the y. So these values between minus pi by 2, let me check here. Yeah, this is minus pi by 2. And till this, it's going to repeat again. So they are going to repeat it here. Uh, Here it is. Let me click here. Then let me click here. Let me click here. See these are the same value that you see here. So this one, and this is the same. If you see this minus 7, 1.7, this again thing. Minus 0.5 is right here, and it minus 0. And it's right here. So this number is right here, and this pi by 3 is right here. So they all get repeated. Basically, what I'm saying is this thing is the same as this thing. See, so both have the same y's. So in other way, we say the period of tangent is pi. So I'll take off the tangent and put a cotangent COT. So let me put cotangent COT. Okay, so this is how the cotangent will look like. To see it more beautiful, I'll put this is minus 2, and this I'll put 2. And we don't want to have too much of this, so I'll put it like only maybe 6.28, which is actually pi, 2 pi. And this I'll put minus 2 pi. Okay, so this was the graph tangent, which I'm changing now. I don't want 10. So yeah, let me take off this and put the cotangent. See this? So the cotangent looks like this. And it is undefined for 0. So you can't have I'll have to say this one cotangent is cosine over sine. So I have to take off this, not this. So minus pi maybe, pi, 0 also, then 2 pi, 3 pi, all multiple of. So if I take this off, and I can see this one, and I did not put that 0, okay. I don't want this, minus pi, then I think I should put 0 somewhere here, 0 x equals 0. There you go. So you have pi by 2 minus pi, 0, pi, 2 pi. See? Oh, so the graph repeats from 0 to pi and starts from top and goes down. If you go and click on the cosecant, let me go cosecant graph, look at the graph. Both cosecant and cotangent have the same domain. They cannot have odd multiple of. So what did we learn from here is, and you can see these are the ones where there's a vertical asymptote at minus pi, 0, pi, 2 pi. So we can say, hey, x can be anything but should not be n pi. And for n integers, because cosecant, what is cosecant is 1 over sine, and cotangent is cosine over sine. So both have sine here, and they are undefined for the when the denominator becomes 0 for sine when it is when the angle is 0, pi, 2 pi, 3 pi, and so on. So hope that helps this video to understand uh, what is the domain, the range, the cosecant and the secant. Let me take off this and secant. See this? Cosecant and secant both have the same range. They start from -1, it goes up, and then all the way down in -1 until. So there is a in-between break there. It's not defined. You can see here. There's no graph. So here it's just empty. This is empty. So there is no graph for cosecant and secant. But you have to be careful with what is the domain. You can clearly see here for this is the secant graph, and you can see. So the secant graph is undefined for odd multiple of pi by 2, but this graph, which is a cosecant, is undefined for integer multiple of pi by 2. Like you can't have 0, pi, and 2 pi, and like that. So very tricky. So we need to know in the next video, I'm going to show the inverse. What is the inverse of all these sine, cosine, tangent functions? So let me wind up this video. So I'm going to wind up this video. Okay, and then let's start with sine. The first thing that we learned, okay, so finish. The first thing that we learned is sine graph, right? That's the sine graph. Oh, cosine graph. Let's check the cosine. Where's cosine? So both sine, cosine, they look alike. Sine start with 0, cosine start with 1, and it's the same shape. Domain is every real number, but the range is from -1 to +1. Let me take this one, then go with the tangent and the cotangent. See, they have infinite, the range doesn't matter, everything, but the domain it depends on a situation to situation. And so they look alike. And main thing what I want to show, they have the same period, 0 to pi, not 2 pi. Because the sine graph, the sine and the cosine have got 2 pi because the cycle continues from 0 to 2 pi and repeats again. But for tangent, it's not like that. It's not how it is. You see, it. Let me take only cotangent. So cotangent goes this way until pi. From here to pi, and the same thing from pi to 2 pi. Same repetition every. That's it. And finally, cosecant and secant, they are U-shaped. See, so the secant start. This is lowest it goes here, but this one goes at pi by 2. So this is all about domain range of all trigonometric equation, how the graph looks like, what is the period. That's all this video is. The next video I'm going to make is about inverse. How will this go up and put a minus, and how that graph will look like. And I'll just print off, just want to show. So I just click here and you can see that how the graph look right. If you click on the sine graph, and you can see I can just separate this, and I should restrict this from p from 0. There you go. So if I restrict and the q, I'll have to go to I can do this even from minus pi divided by 2 and q as pi divided by 2. Let me take this off and then put a all slider and put p is minus pi by 2.